Hello, and today we're going to talk about graphing with irrational functions. I found some sheets that I think will help just from the organizational standpoint to help you get used to the graphing part of this. So we're going to walk through a couple of things. You're welcome to print these notes out or make notes on your notebook. I actually printed these out, and some folks wanted the printed copies today. So if you want to print these, you're welcome to print them and use them as you wish. I think one of the things that we get caught up with a lot of times when we go to graph is that we need to factor first. We have a tendency to just want to dive right in and do whatever we need to do and get it done. But we need to simplify first when we do these. Okay. When we're talking about finding the x-intercepts, we're talking about finding the zeros. So that implies that I am going to set the numerator equal to 0 and solve. Now, I would, in other years, I would assume that you remember that from Algebra 1 and Algebra 2, but I also know that COVID hit last year, and some of you had Algebra 1, Algebra 2 during COVID, and some of this is not quite as fresh as I would like it to be. So for those x-intercepts, we're going to set that numerator equal to 0, and we're going to solve. The y-intercepts, you're going to fill in 0 for x and solve. For your vertical asymptotes, you're going to set, and I'm just going to write this over to the side because I know you're not going to be able to see it. For the vertical asymptotes, you need to set the denominator equal to 0 and solve. Okay, horizontal asymptotes, we need to use our rules, and these are a little bit backwards from what you're used to seeing. When we wrote our rules down, we said if the degree of the top is less than the degree of the bottom, then the asymptote is y equals 0. If it is equal, then you have y equals the leading coefficient, and I'm going to abbreviate here, of the numerator over the leading coefficient of the denominator. And remember, we said if it's greater, if the difference is exactly 1, then we have a slant asymptote, and that is our Q to divide. Otherwise, there is no horizontal asymptote. Okay. The last one was the holes. We talked about finding the common factors. What can I cross off? And those are my holes. And we'll talk about some of that with holes here in a minute. So those are the things that you need to get used to doing on any problem when you're looking at graphing. Now, with graphing, we need to look at the major points, which is what these are. And we're also going to let our calculator help us some as we put some of these in the graphing calculator. Okay, but we want to get these points nailed down first. So if you'll look at the first one on this set of notes, we have a couple of functions here. And the first thing I need to do is I need to look and say, can I factor this? And the answer is no, it's completely factored. It's perfectly fine. So I'm going to go ahead on this graph because I really don't like the way these graphs look. I don't know about you, but I can't tell where the axis is. And I'm going to color over my axis so we can tell where it is. Okay. Okay, so that's my axis. All right, so the first thing we're going to do is we're going to figure out what is my x-intercept. And remember we said the x-intercept is we're going to set the numerator equal to 0. So for my x-intercept, I'm going to take x plus 1, and I'm going to set that equal to 0, and then I'm going to solve it. So x is equal to -1. So my x-intercept is -1, 0. So I'm going to go ahead over here. I need to clean this up just a tiny little bit. I got excited over here with my axis. And I need to put a dot at x equal at -1, 0. So let me change this to a red. And helps if I change the right thing. Okay, I'm going to go to -1, 0, and I'm going to put me a dot right there because that's where it's supposed to cross the x-axis. Okay, all right, so it says for the y-axis, I need to fill in 0 for all the x's and solve it. So I'm going to go back to my book here. So for my y-intercept, I'm going to put in 0 plus 1 over 0 minus 5. And that's going to give me 1 over -5, or -1/5, or -0.2. So I'm going to have 0, comma, -0.2 as my y-intercept. So on my graph, on my y-axis, I'm going to go to -0.2, which is going to be really difficult to see. So I'm going to say it's right in there somewhere. All right. So the next thing I need is I need my vertical asymptote. So that means I'm going to take my denominator. So I'm going to say VA, vertical asymptote, x minus 5 equals 0. And when you solve that, you're going to get x is equal to 5. So I have a vertical asymptote at x equals 5. So that means that I cannot go across x equals 5. So there's 1, 2, 3, 4, 5. So this is it right here. So I can't go across this line right here at x equals 5. And if you think about it, that makes sense because the denominator cannot be 0. And if you put 5 in there, it's going to be 0. All right. So the next part is we need the horizontal axis, the horizontal asymptote. So the degree up here is 1. The degree down here is 1. So my leading coefficient here is 1, and my leading coefficient here is 1. So for my horizontal asymptote, I have y equals 1 over 1, or just 1. So I have y equals 1. So at y equals 1, I'm going to have another asymptote. Now these are lines I cannot cross. So there we go. All right, we do not have a hole. None. Because we don't have anything to factor, so we don't have any holes to cross off. Now, I believe the video that you watched talked about the domain and the range. Just remember that domain and range are going to be affected by asymptotes and holes. And in this case, they're going to be affected by those asymptotes. So I have x. such that x cannot be equal to 5 because that's where my vertical asymptote is. My y values are restricted where my horizontal asymptote is, so y cannot be 1. Okay? All right, so let's look at this next one. This one says that I have x squared minus 2x minus 15 on the top. The first thing you should ask yourself is there any way I can factor this top? And if there is, I need to go ahead and do that and get that out of the way. So if I factor this, I want things that multiply together to give me negative 15 that add to give me negative 2. And that would be x minus 5 and x plus 3. Okay, now just by looking at that, you should know that you have a whole because both of these have x plus 3's in them. So I have to have a whole at x equals negative 3. Okay, so I'm going to go ahead and get rid of this because these guys right here are going to cancel each other out. Okay, so I'm going to go ahead, draw in my axis here, make it a little darker, since this does not do a great job. Okay, all right, so now we're going to work with the factored form of this, and we're going to do all the things that we talked about earlier. So the first thing I'm going to do is I'm going to set the numerator equal to 0. So all I have left in the numerator for the x-intercept is x minus 5. So I have x-intercept at 5. So I have 5, 0. So put a dot. 1, 2, 4, 5. I better go too far. Okay. And the other value that I need to look at is the y-intercept. Okay. And when I fill in 0 for all of this, so when I say 0 minus 5, I'm just going to get negative 5, right? So I'm going to have a y-intercept at 0, negative 5. So on the y-axis, I'm going to go to 1, 2, 3, 4, 5. Okay. And then I need to do my vertical asymptote. Do I have anything left on the bottom once I factor? And the answer is no, I do not. I don't have anything left on the bottom. So can I have a vertical asymptote if I have nothing left on the bottom? And the answer is no, I don't have one. Okay, so there's none here because I have no denominator. The denominator is just 1. There's nothing to set equal. All right, so I have a numerator who has a degree of 1, and I have a denominator that is a degree of 0. They're exactly 1 apart, but there's nothing to divide. So I have none because basically I have factored out the only thing that was going to give me that. All right, the other thing I need to do is to find the y-coordinate of this whole, I now need to plug in negative 3 over here. So I'm going to say negative 3 minus 5 is going to give me negative 8. So my point here where my whole is negative 3, negative 8. And the reason you need to do that is because that's going to show up in your domain in the range. So for your domain, you're going to have x such that x, we don't have a vertical asymptote, but we do have a hole at -3. So x cannot be -3 because of that hole. And then in the range, we don't have a horizontal asymptote, but we do have this hole that exists at -8. Okay, so those two things exist. Now, several people said, well, what do I do when I get this part and then I don't know what to do? Well, you have a graphing calculator. So you can go in the graphing calculator and look to see what this curve looks like. And as long as that curve passes through or does not pass through the points, okay, in some cases with the asymptotes, as long as it goes through your intercepts and it does not cross your asymptotes, then your graph is usually correct. So on number 3, because you ended up with a straight line, the only thing we couldn't have is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, you'd have a hole right here. But otherwise, you're going to have a straight line down through here. And my lines, I can just go ahead and tell you, are not very straight. Okay? And then this is your hole right here. Okay? All right. So you may want to go in and play with that in your calculator. Remember, when you put this stuff in the calculator, it's best to put the numerator in parentheses and the denominator in parentheses before you start. Okay? The next one that we did in class was number 5. When you look at this one, again, you need to ask yourself, is there any way for me to factor this? And if there is, you need to go ahead and factor it. So I have a bottom that can be factored. And so I have x minus 3 and x minus 2. Okay? Now, immediately you should say to yourself, wait a minute, I have whole. I have whole at x equals 3. Okay, so I'm just going to go ahead and make myself that note over there that I have a hole at x equals 3. And I'm going to have to go back and I'm going to have to plug that number back in here in a minute and find out what my y coordinate is. But the first thing I need to do is notice that there's nothing left up the top. There is something up there. It's a 1. Okay, it doesn't just disappear. There still has to be that 1 at the top. So now I'm going to use this 1 over x minus 2 as my function, now that I have simplified it. And that's what I'm going to do the vertical and horizontal asymptotes for. So if I'm going to do my x-intercept, is there anything to set equal to 0 on the top? Is this a true statement? It is not. So there is no x-intercept. Y-intercept means I'm going to put in 0. So 1 over 0 minus 2, or 1 over -2, or -0.5 is going to be my y-intercept. So 0, -0.5. I guess I'm going to try to put this in here with this and see if it will work. It draws a better line than I do because I don't draw a very good one. Okay, that's a little better. Okay, so I'm going to go in and I'm going to put my points on here. So I have 0 and -0.5 is going to be right in here. Okay, I know I'm not going to touch the x-axis because I don't have one. I don't have an x-intercept. All right, and then the next thing I need to do is my vertical. So I need to set x minus 2 equal to 0. So that's x equals 2. So at 2, I need to draw me a dash line here. Okay, horizontal, the degree on the top, because I don't have an x, is 0, and the degree on the bottom is 1. So degree on the top is smaller than the degree on the bottom, so it's y equals 0. So here is my other asymptote, okay, which makes sense because we don't have an x-intercept, right? All right, so the next thing we need to do is we need to plug this 3 in up here and see what we get. So I have 1 over 3 minus 2, which is just 1 over 1, which is 1. So my whole is at 3, 1. So I'm going to go to 3, 1, 2, 3, 1. And I'm just going to put my whole there. Okay, I know I'm not going through that. Now, I want you to think through this just a little bit. When we talked about transformations, we had a function called the reciprocal function, which is 1 over x. And 1 over x is the function that has 2 separate pieces to it. This minus is underneath with the x, just like it would be in a parentheses. So this is saying that I'm going to move this to the right 2. So I'm going to pick it up and I'm going to move it to the right 2. So basically by creating these asymptotes, what I have done is I have picked this function up and I have moved it over to the right. So I basically have taken my axes and I have moved them over. And then I'm going to draw that curve through that, around that point. And you can look at this on your graphing calculator. However, remember we discovered the other day that the holes don't show up. So don't be aggravated or disgusted because you don't get your hole. They do not show up on the graphing calculator. Okay, just make sure they don't hit those asymptotes. Okay, so my domain here is going to be all numbers except x cannot be 2, and because of my hole, it also cannot be 3. Oops. My range, because of my asymptote, cannot be 0, but because of my hole, cannot also be 1. Okay. All right. This next one, we had a long discussion in class about this one, about the difference of 2 squares. So when you're looking at a squared term and you're missing the x in the middle, the first thing you should ask yourself is, are these perfect squares? What times itself can give me 4? What times itself can give me 9? And try to figure those out because you have a difference of 2 squares here. With the difference of 2 squares, you have a plus and a minus. So what times itself gives me 4 is 2. What times itself gives me x squared is x. What times itself gives me 9 is 3. And then on the bottom, both of these have 2 in them, so I'm going to take that out. And then I'm going to ask myself, well, wait a minute, do I have the same situation on the bottom? And I actually do. So what times itself gives me x squared? What times itself gives me 1? So I have 2 times x minus 1 and x plus 1. And it doesn't matter which order they go in as long as they're there. Go ahead and put my axis on here because we're going to need this. I didn't change my color so you get red this time. Oops, lost it. Let's try that again. There we go. Okay, now All right, so we need to go through and we need to do all our points on this one, and I'm going to do this rather quickly. The first thing we're going to do is we're going to do those x-intercepts. So we're going to set these two top things equal to 0, and we're going to solve those. Okay, and you're going to get x is equal to -3/2, or 1.5, and x is equal to 3/2, which is 1.5. So I have an intercept at 1.50 and -1.50, and you're welcome to leave those. I'm not going to be picky about the fractions and the decimals and all that good stuff. All right, so there's my 1.50 and my -1.50 is right there. So we know we have 2 points. Okay. All right. For my denominator, oh, we got to fill in 0 first. So if I fill in 0 here at the top, if I fill in 0 here, that's going to give me 0. That's going to give me 0. And I'm going to end up with -9 over -2, which is 4.5. So I'm going to have a 0, 4.5. So 1, 2, 3, 4.5. Okay. And that's going to end up being a really important point when we look at the graph. Then we need to do the vertical asymptote. So we're setting anything on the bottom equal to 0, which is that x minus 1 and the x plus 1. So I have a vertical asymptote at 1 and -1. So I have an asymptote right here. Now remember that asymptote's a line I can't cross. And I got some points that are awfully close to that line, but I still can't cross it. Okay, and the same thing with -1. And it doesn't matter that that point is right over there next to that, you still can't cross that line. Okay, all right, so the next part of this is we need to do the horizontal asymptote. So if I'm looking at this, and both of these have a degree of 2, so my horizontal asymptote is 4 over 2, which is 2. So y is equal to 2. So y is equal to 2 is my horizontal asymptote. Looks like I got somebody, this point over here at the top boxed in. So we don't know how he's going to react. We don't have any holes, so we can say none here. Okay. Now, when we go back up here to do the domain, remember that that is going to be affected by your vertical asymptote. So I actually have 2 numbers that it cannot be. It cannot be 1. It cannot be -1. It's also, y is also affected by your horizontal asymptote. So y cannot be 2. Now, when you look at this graph, in the graphing calculator, what you're going to see is you're going to see a curve that looks something like this. So I have a 2 curves on the bottom. Oops. And I have a curve at the top in this little bitty space up here. Okay. So that's where all those points get covered. As we look at some of this, I think the big thing is to go back through and to make sure you factor first, and then use this format to help you get through all those points that you need in order to graph. Now, just a reminder about slant asymptotes. When you do a slant asymptote, I don't care whether you divide or whether you line divide or whether you synthetic divide, but if you need to divide, you need to divide. So these two have to be a degree that are 1 apart. So this is a 2 and a 1. Those are 1 apart. If I do 2 minus 1, it's 1. So I need to divide these two. And since there's nothing in front of this x, I can use synthetic division. So I'm going to use synthetic division. Remember that with synthetic division, the function has to be an x minus h. So this is actually going to be a -4 that goes in here. And then I need the coefficients of all my terms. So 1, -1, and -14. Bring down your first number. That's a 1. 1 times -4 is -4. You're adding. -1 plus -4 is -5. -5 times -4 is 20. And that gives me 6, but I don't care about the remainder. So this is x minus 5 is my result. Okay? Now, when there's a number in front of that x, unless you love fractions, don't try to do it synthetic. Just don't even try. Okay? So this one needs to be done long division. So I have 3x plus 2 out here and 6x squared plus 4x minus 11 out here. So what do I multiply 3x by to get 6x squared? And that's a 2x. So that'll give me 6x squared. 2x times 2 is 4x. And remember, when you do this, you're always subtracting. Okay, this is going to give me 0. And we're going to bring down that minus 11. So do I need to do anything else? All I have left is this minus 11, which is a remainder that I don't care anything about. So my answer is 2x. Okay, so you need to keep that in mind when we do these next couple. The ones they chose in class to do were numbers 5 and number 10. So those are the two I'm going to do on here. So, no, I'm sorry, number 7 and number 10. So number 7, first of all, it looks like it needs to be factored, and it does. So if I factor this, this is going to be 2x plus 5 and 3x minus 2. And I have 2x minus 1 on the bottom. Okay. All right, so for my x-intercepts, I need to set the things on the top equal to 0. And I'm going to solve. So subtract 5 and get 2x equals -5. Divide by 2. So I have one intercept at -2.5. And then I add 2 on this one and divide by 3. And I get I rounded this off, 0.7 and 0. Let me go ahead and fix my axes over here so we can actually see what we're doing. Not like where that is. There we go. Okay. All right, so I need to put a dot at -2.5. And I need a dot at positive 0.7. Okay. All right. So now I need to do my y-intercept. So if I fill in 0 here, 0 here, 0 here, I get -10 over -1, which is 10. So this is 0, 10. And actually, he's not going to fit on my graph, so I'm just going to leave him off. He's going to be down here off our graph somewhere. The vertical axis, the vertical asymptote, I'm going to take the 2x minus 1 and set it equal to 0 and solve it. So 2x equals 1. So x is 0.5 or 1/2. So x is equal to 0.5. So I'm going to have a vertical at 0.5. Now these guys are going to be hugging up next to each other. This intercept and this asymptote are just about side by side. So they almost look like they're going through each other. Okay, but they actually don't. Okay. And I'm probably not going to take the time to graph this, but there is no horizontal because they're one apart, so that means I have a slant. So this is a slant because this is a 2 and this is a 1. So I've got to divide, okay, and I'm going to use the space up here for this one. And because I have this 2 in front of this, I need to do long division. So I have 2x minus 1 and 6x squared plus 11x minus 10. What do I multiply 2x by to get 6x squared? And that is 3x. So that gives me 6x squared. 3x times negative 1 is negative 3x. Subtract. Okay, so that's going to give me 14x minus 10. What do you multiply 2x by to get 14x? And that is 7. So 14x minus 7. Now, am I even worried about my remainder here? No, not really. Okay, so you end up getting a remainder, but I'm not even going to worry about it. So your slant asymptote is y equals 3x plus 7. Okay, there is no whole because I had nothing to cancel out. Okay, and the domain and range will take care of it a little bit. Okay, all right, number 10 is, I believe, the last one they asked me to work. And on this one, they wanted to see it because I told them that they could do synthetic on it. And so they wanted to see how they would use synthetic on this. So if you'll notice on the top, you can factor out an x. So you get x squared minus 1. And on the bottom, you can do x minus 1 and x minus 1. So this is a perfect square. So you can continue to factor this, and it's x minus 1, x plus 1. And you'll notice that you do have a whole. Okay, it ends up not being a whole, but anyway. Okay, so we did this one because we said that this would be a whole, and this would be x equals 1. Okay, but notice what happens when you do your vertical asymptote on this. When you set this equal to 0, and this is a problem you don't see very often, you're going to get that your vertical asymptote is x equals 1. So basically, your whole and your vertical asymptote are on the same line. So vertical asymptote trumps whole. Okay, so we list the vertical asymptote at x equals 1. Now, there is no horizontal because this is a slant. Okay, and for my slant, what I reminded them of is now you can multiply this back together. So this is x squared plus x over x minus 1 after you get rid of these right here. So now you can do synthetic. You in the minus, so you have 1 in here, and you have 1, 1, and 0 because you have no constant. And then you can go through and do synthetic on this. So your slant is y equals x plus 2. Okay, so, and you continue to do the same things for the top. All right, so that should give you some help getting starting on graphing. There will be more practice tomorrow. The plan for this week is for you to do graphing today, reviewing Tuesday and Wednesday, and then you will have a take-home test, a test that you do at home on Friday. So it will be a paper and pencil test that you have to do your work and show your work and send us a picture. So we're trying to get ready for that. So just keep working on the graphic.